forgive me. I'm just warming up on some calculations, yes? Well, it's good to see you again, my fellow space cadets. Dr. Phineas Cortex again, at your service. Now, I'm sure you remember last time, our last broadcast, that I discussed a new segment to the transmission. The question of the day. Yes, I will be doing that at the beginning of each episode. Now, I will be taking questions from you, all of you, in the comments section. Yes, yes. And I actually received a question from the last video. This one is from Haley. And Haley, she asks, "Dear Dr. Cortex, how many stars are in the universe?" My word, Haley, that is quite a difficult question. But we can get to some answer via logic. Now, scientists have deducted through extensive studies that there are about 100 billion stars in our galaxy, the Milky Way. I'm sure many of you know that. Now, take the observable universe before you. Assuming that the average amount of stars per galaxy is set to 100 billion, and there are about 10 billion galaxies within the observable universe, then it is safe to say that there are about 1 billion trillion stars in the observable universe. That's quite a large number. Keep in mind that is the observable universe. That means everything that we as humans can see with the technology that we have today. Now, who knows how far the universe expands? Hundreds, thousands, trillions of light years, and trillions of stars as well. I mean, there are infinite amounts of stars everywhere. No lie. Appears that I have something in my mouth. You'll have to excuse me. It's nothing. It's nothing. Just a bit of space dust, that's all. But as I was saying, very good question, Haley. I admire your efforts. Now, on to the main part. Yes, I'm sure many of you remember that we last discussed the planet Mercury. And of course, on our glorious trek across the solar system, the only other step we can take is Venus. Computer, take us to Venus. It's really quite a wonderful piece of machinery. It doesn't make a sound at all. Now, I went ahead, as usual, and I brought some data. And it's quite interesting. Now, Venus is named after the Roman goddess of love and beauty. For all of you mythology experts out there. Now, I'm sure many of you remember that I told you Mercury was the closest planet to the Sun. Despite that, Venus, being 67 million miles away from the Sun, making it the second closest planet to the Sun, it is the hottest planet in the solar system. And there's a few reasons why. First of all, it has a really, really thick atmosphere. Think of the Earth's atmosphere, yes? I'm sure many of you have heard of the ozone layer and how it keeps in some of the heat that the Sun puts out on Earth. Well, think of that magnified on Venus. Venus's atmosphere being 96% carbon dioxide and 3.2% nitrogen, it is sort of like a really, really thick sweater that you don't want to wear on Christmas. You see, it traps in a vast majority of the heat that the sun puts out on it. In addition to that, Venus has these systems of sulfuric clouds that sometimes rain sulfuric acid that makes really things sort of acidic, if you will. Now, because of all of this happening, Venus's temperatures, both day and night, stay at a sort of, well, modest, I don't know if it's really scorching 870 degrees Fahrenheit. It's ridiculous. It really, really is. That is hotter than the planet closest to the sun. I mean, you really wouldn't expect it. But there it is. Sort of another thing that contributes to Venus's hotness is its rotation and revolution period. Now, Venus's day lasts 243 Earth days. And also, Venus's year, or revolution around the sun, lasts 225 Earth days. So, in a sense, well, I say in a sense, literally, a day on Venus is longer than a year on Venus. It's incredible. It really, really is. And because of that, the sun really has enough time to bake one spot of Venus. And because of that, get this, people, or a person, so to say, if he or she lands on Venus without any protective equipment, they will last less than 1 second on the planet's surface. And it is so hot there, in fact, that lead and tin, some of the strongest metals around, will melt like ice. I would not want to go to Venus if I were you. If I were a smart person, I would not want to go to Venus. Now, despite all of this, Venus is sometimes called Earth's twin. In terms of size, yes, that would be correct. Venus, if you will, down here if you can see it, the diameter is about 7,520 miles, which is about 95% of the Earth's diameter. And that's about all of the similarities there is. No moons, no two-layer core, just nothing, no life, nothing. I mean, I don't know why people would call Venus Earth's twin. I mean, that's really all the similarities. That's really it. Oh well. Now, let's not dilly-dally. The interior of Venus. It is mostly made of solids, rather than, say, the Earth's liquid mantle and Earth's liquid outer core. Venus has an entirely solid core and mantle made of iron and nickel. And it's because it is solid that Venus actually has a weak magnetic force between its poles. Now, although it is completely solid inside Venus, the crust of Venus is particularly interesting. There has been evidence that Venus's crust has volcanic activity and geological activity, so to say. All of these gases that are in the air, they are produced by volcanic vents and, of course, volcanoes throughout the surface of Venus. In addition, there are these, how you say, pancake domes, or sort of flat plains across Venus that have been formed from the heating and the cooling of lava. And furthermore, the highest point on Venus, a mountain called Mat Mons, it's about 5 miles high from the planet's regular ground level. It has been seen spewing amounts of lava material, which is really quite interesting. And it goes to show that Venus in itself is an active body and planet in space. It is really, really quite interesting. I must say that this is the first exciting point in our journey, so to say. And I must say, all this excitement has gotten me rather hungry. You know what time it is, my fellow space cadets? Jambot! Have you got a particularly warm snack for us?
Boy, do I have a hot dish for everybody today. By gathering more schematics from the planet Venus, I have created a recipe called Venus Sliders. Young space cadets, be 100% sure that you have a parental unit with you when making this. Now, to make Venus Sliders, you need, 1 tablespoon of olive oil, half a cup of chopped onions, half a cup of green or red peppers, 4 slices of bread, 3/4 of a cup of shredded cheese, and 1 tablespoon of softened butter. Now, pour the olive oil into a skillet and heat the oil over medium-high heat. Then, saute the onions and peppers until tender. Take 2 slices of bread, spread the shredded cheese on 1 slice, and spread the outsides of the sandwiches with butter. Carefully put the sauteed onions and peppers into the sandwich, and toast the sandwiches in the skillet until golden brown. That's how you get this delicious meal. But back to you, Dr. Cortex.
Thank you very much, Jambot. My taste buds are already tingling as we speak. And you know something else? I've already forgotten the next spot that we have to visit. Daggone memory of mine. I can't remember a thing when it comes to these. I'll have to ask the computer again. As always, excuse me for one moment. Computer, what are we going to discuss next time? Another piece of paper. I see. Well, I do believe that this next topic will be rather interesting. For the next time we meet, we will discuss Mars, the red planet itself, and quite frankly, our closest target when it comes to outer space exploration. Other than the moon, of course, yes? Well, my friends, the time has come for another video's end. I do hope you'll join me next time as we discuss Mars, as we have said. Another shout out to Haley for providing us with our question of the day. Good question, really, really good question. Now, with all that being said, I bid you ta-ta. Now, ready for our salutes? Yes? In 3, 2, 1.